So normally, for those of you who've been coming to 60 Minutes in Space, you know that I'm an astronomer, and so I tend to cover things outside of our solar system. But it turns out that for today, my story will be about the New Horizons spacecraft, which is definitely not outside of our solar system. But many of you are aware that over New Year's, New Horizons, which explored Pluto 3 years ago, flew by another target, something called Ultima Thule, a Kuiper Belt object. It's one of these potentially billions of small icy bodies that orbit beyond Pluto and Neptune's orbit, so they could lay out to maybe twice the distance of Pluto and Neptune. And I was invited to the New Horizons flyby of this most distant world, which actually occurred on New Year's Eve of this year. And so it turned out, because it was New Year's Eve flyby, they decided to basically make a big party out of it. And so what we'll do is my wife and I were both there out in Laurel, Maryland at the Applied Physics Laboratory, which is the institution that actually runs the spacecraft, although a lot of the scientists involved with the New Horizons mission, including Alan Stern, who's the chief scientist with the mission, is actually based in Boulder, Colorado at the Southwest Research Institute. So what we did was we went out there well, initially to just enjoy what was going to happen at the flyby, but then we thought, wait, we can go and interview a bunch of scientists and engineers and find out what they think about New Horizons. And so what we did was we put together a video which was edited with the help of Kim Evans, who's in our programs division here at the museum. And so this is the very first video that I've created for 60 Minutes in Space. So hopefully you'll like it, and after the video, we'll look at some more results from New Horizons. So the video will be a lot of talking heads, but hopefully you'll also get a sense of what happened at the flyby on New Year's Eve. Okay, so let's get.
The revelations of New Horizons may help us to understand better how our solar system was formed.
The plan was to explore Pluto and the Kuiper Belt, which is this zone of millions of other small frozen objects out beyond Pluto. But when New Horizons was launched, there wasn't an object that was known that New Horizons could get to. Pluto is the only Kuiper Belt object that has been explored. It's the largest one we know of. It's a big round dwarf planet, whereas this object, whatever it is not a dwarf planet. It's too small to be rounded by its own gravity. So by anybody's definition of planet, it is not one. It's one of these objects that was left over from the planet building process, and we imagine that it has important clues as to how that planet building process occurred.
We've never seen a body this small from this part of the solar system that has never been really disturbed by gravitational disruptions or large bodies moving through it. So the body that we're looking at has never really been close to the sun. And we don't know what that's going to mean for what we're going to see.
Our current understanding of the Kuiper Belt is that of an extremely diverse population of dwarfs. On one end, we have the largest objects, dwarf planets like Pluto, with active geologies, atmospheres, surfaces covered by organic materials, water ice, and again methane, nitrogen, carbon monoxide. On the smaller end, we have primitive, volatile, poor planetesimals, what we know of as building blocks of the planets. And Ultima Thule is one of them.
It was actually very dramatic. As New Horizons went out towards Pluto, It was assumed that observations with telescopes on the ground would reveal multiple objects that would be easy for the spacecraft to get to. In fact, it turned out to be really hard.
We used a whole bunch of ground-based telescopes. We searched for a long time, and we came up completely empty-handed. We found a lot of KBOs, but we didn't find anything that was close enough to the path of our spacecraft to get to.
Time was getting short, and they were not finding an object they could get to, and it got kind of dicey. And they sort of called in the Hubble Space Telescope at the last minute and found this object sort of just in the nick of time. So it was really fortuitous.
In 2014, actually the beginning of 2014, we said the chances are not looking good here. We're not getting it from the ground. So we retooled to search for the Hubble Space Telescope and then processed that data. And so I was the one that discovered the object with our team, but I was the one that saw it first. So I discovered that.
There are quite a lot of things that make it harder than the Pluto flyby. One is that this object is really small. It's only 20 miles across, and compared to Pluto that was 80 times bigger. And so targeting our images is more challenging.
It's very small and very, very faint. So as was said during the day, it is very important to get the pointing right and the trajectory right. The other difficulty is the distance. It's very far out, and this contributes to the faintness of the object.
This object is much darker, so we don't see, we just won't have as much light to work with. Our exposures have to be longer. There's a danger that the images may be blurry if we don't hold the camera steady enough, and so that's more difficult.
There's also the scientific challenges. So Pluto, we knew the questions when we launched. We could build our instruments and design our sequence because we wanted to know for decades why is the surface dark in some places and bright in the other? Why is there a spot that seems concentrated in carbon monoxide? How much methane is there in the atmosphere? We had these burning questions that we wanted to answer and tie it all together. Ultima Thule we only discovered in 2014, and it's been a dot until this afternoon in everything from Hubble Space Telescope to our own spacecraft. So we had to design the sequence with our eyes and brains completely wide open.
I spent 30 years working on Pluto, building up to the flyby. Okay, and I knew a lot about it. I'd studied it lots of different ways, thought about it, but it's decades-long process. With MU-69, it's all packed into 4 years.
The navigation is incredible. The precision and the distances involved, and the fact that they have to do it by comparing, our best database of star fields with, model where we think the spacecraft is and where we think the target is.
You already know that Hubble takes some amazing images, but they're not good for measuring positions without a good star catalog to say, okay, you see MU-69 against a bunch of stars, where are the stars? Gaia, the European Space Agency mission, came along at just the right time to get us an unprecedented level of accuracy for the star positions. This extended mission would not have been possible without Gaia and getting their catalog done in time. And they actually gave us early access to the data to buy us a year on our planning.
The Pluto flyby, we started getting images down weeks before. We had some low-resolution images, and then every day it would be a better and better image. And the same thing is happening for Ultima Thule, but much faster. So only 3 days before, we got the first images where the object was more than 1 pixel. And then it went from 1 pixel to it's going to be 1,000 pixels in just over 3 days.
We're much farther away from Earth, so the round-trip light time is longer. At Pluto, it took 9 hours to send a command to the spacecraft and get a response back. The region that we are now, just beyond Ultima Thule, that round-trip light time is 12 hours. So even at the speed of light, we send a command, it gets to the spacecraft about 6 hours later. Another 6 hours after that, we get a response.
At Pluto, we were getting data rates of about, or as high as about 2,500 bits per second. When I was a kid and people had their 56K modem, we're getting about half of that. Well, now we're so much further that we only very rarely get above 1,000 bits per second at this point. And so it's very slow coming back, and waiting for that data to trickle in is painfully slow sometimes, but we know it's coming, and we just have to wait for the light to get here.
Who knows? There's a possible plan to find another object for New Horizons to fly by. That's going to be very hard given the navigational and imaging possibilities and the sparseness of objects out there. But if crossing our fingers, maybe we'll get to do it all again.
Our extended mission for New Horizons isn't just about this one flyby, although that's certainly the big highlight of it. We're going to be using LORRI to observe those Kuiper Belt objects that are 1 million miles away from the spacecraft, which doesn't seem like it would be worth doing, but New Horizons is a whole lot closer to these objects than any other spacecraft has ever been.
As we look from the side, which New Horizons can do because it's there among all these objects, it's looking at the light that's scattered not just straight back towards the sun, but off to the side. And so that's giving us some unique information about what these surfaces are made of.
That's going to really help us understand even just the properties of the materials on the surface. And so that can still be really helpful for understanding what geology is possible on other worlds in the Kuiper Belt.
In the Countdown Central, and as you can see, it's a big old party. Everyone's having a great time. We are so excited to be here for this historic flyby. This is the farthest thing that humans have ever explored.
We've got a rock star much closer to home, Brian May, astrophysicist, New Horizons contributing scientist, and lead guitarist for the rock group Queen.
It's my privilege and my pleasure to introduce to you right now the world premiere of this new theme for New Horizons. Thank you.
You guys ready? Are you psyched? Are you jazzed? 5, 4, 3, 2, 1. Go New Horizons! Go New Horizons! Woo-hoo! Woo-hoo! Woo-hoo!
And lock with telemetry.
GNC looks good.
Copy. GNC is good.
All right. Power is green.
Copy. Power green.
C and the H is nominal. Our SSR pointers are right where we predicted, so it looks like
Copy that. We have a healthy spacecraft. We've just accomplished the most distant flyby. We are ready for Ultima Thule science transmission.
Now, the image that I'm about to show you is the best image of Ultima that we got pre-flyby. There it is. Meet Ultima. That image is so 2018. Meet Ultima Thule. Now, being scientists, we're not all that creative with words, so what we've decided to do is name one lobe Ultima and the other Thule.
At Pluto, one of the scientists had been part of the Voyager team. And I remember as a kid, I was in the 4th grade when Voyager 2 had gotten past Uranus, and I remember there being no information to there being all this information. We knew about rings and we knew about moons and all of this stuff that we hadn't known before. And so to get to be a part of that for Pluto and now for Ultima Thule, it's astounding. And I am so glad to get to be a part of this team.
It's amazing to work on this mission, and what's really cool is that NASA and the people in the U.S. have chosen to explore the solar system like this. Like, this is a public mission. Everybody can go and download the data from NASA's website. Everybody can participate in the excitement of exploring the outer solar system. We're thrilled to be here and hope it's going to be continuing for a long time.
We really kind of feel like a family. We spend a lot of hours together, and working towards something this amazing really brings us close together, and it's been a fun journey. It was a real relief to see that signal this morning and know that we accomplished that flyby.
So what I'll do is just go over not only the images that were released during the first couple of days of the flyby, but the subsequent ones that the New Horizons team has released. So you saw this in the video. This was put out the day before the flyby. And so this left image shows just a handful of pixels for Ultima Thule. Each of these pixels is roughly about 6 miles across. And what they were able to do was to take a bunch of these images and combine them together, and using a scientific image processing technique, they were able to recover more resolution than this. So you get this extended view of Ultima Thule. And this was the image that was released the day after the flyby. So basically, because it took 6 hours for any radio transmissions to travel back from Ultima Thule and New Horizons, that meant that the team wouldn't actually get any data until the morning after New Year's. So this is from New Year's Day, and when you saw the video of the mission control actually getting all the information back from the spacecraft and learning the spacecraft was healthy, that was actually at 10 a.m. in the morning. And so the flyby occurred about 12:30 a.m. New Year's Eve, or New Year's morning. And the spacecraft didn't actually, the data from the spacecraft didn't get back to Earth until more than 9 hours later. And so this was the best picture that was sent back pre-flyby. And so you have kind of a peanut or bowling pin shape. And they were able to combine the pictures together of leading up to the flyby. And so this is only about 8 hours worth. And so you can see how quickly Ultima Thule grows from just a pinprick, just a dot in the sky, to this enormous object that fills up the field of view. And then there's also another animation where they hold the size of the object steady, and so you can see it getting clearer and clearer as New Horizons flies up to it. And the team, the New Horizons spacecraft has multiple detectors on board. And so one of them is a color imager, but because the color imager has lower resolution, it's about 5 times worse than the high resolution black and white imager, they were able to take the better looking black and white image and combine it with the color to give you a sense of what it looks like in color. And what the interesting thing that they find is that the color of Ultima Thule is pretty uniform, so there's not much change, but the neck where the 2 lobes meet is definitely brighter. So that seems pretty interesting. And so this was the best image that the team had released to the public on January 2nd, 2 days after the flyby. And just a few weeks ago, or actually about a month ago, on January 24th, they released a much higher resolution image. As one of the flight controllers said in the video, because the spacecraft is so far away, 6 billion miles, or is it 6 billion kilometers, and 4 billion miles from Earth, they have to send the data back at extremely low data rates in order to minimize errors from the data stream. And so it's going to take on the order of about 18 to 20 months for all the data to be sent back. And so what this means is that we'll be learning for the next year and a half more and more about Ultima Thule as progressively higher and higher resolution data and both images and other types of data are sent back. Here is an animation showing Ultima Thule from the backside. And so what happened was after the spacecraft flew past it in the flyby, it turned around and was able to image it from the back. And what they're, by looking at the stars that were blocked out by the body of Ultima Thule, and then also looking at this edge that's sunlit, they were actually able to determine a much better model for the shape. And so instead of that snowman model that we saw, it's actually more of a flattened object. So you have kind of a flat, what they call a flattened walnut, and then another pancake. So we have the second use of pancake tonight for the other lobe. And what's really interesting is that when they created an animation early on, just a few days after the flyby, and they combined two different images taken at slightly about half an hour apart, you can even tell that this lobe appears more flattened as we flip back and forth between those two images. And then finally, just about 5 days ago, this was released, and so currently this is the highest resolution image that we have of Ultima Thule. And right now, I'm not a planetary scientist or planetary geologist, and the New Horizons scientists are busily working on trying to figure out what this and other images that they're getting and the public isn't seeing, what those images are telling us. But what we're seeing is not only a lot more detail of things that might be craters, like over here, but there's, we still see these, this giant cavity, which could be a crater or it could be sunken because material boiled off. There might have been volatile ices that got heated from sunlight or from other sources of heat, and that, as that material boiled off, this area collapsed inwards. But right now, that's just speculation, and there's also a lot of speculation as to what this bright ring is and what all these other bright spots are. And so over the next few years, even after all the data has been sent back, scientists will continue to work on Ultima Thule to try and understand what we're seeing and how it got to be this way. Because initially, it was thought that Ultima Thule resulted in two sort of roundish objects that had a very gentle collision, only a few miles per hour. And as Jeff Moore, one of the mission geologists, said, this is so slow that if this happened to you in a parking lot, you probably wouldn't bother calling the insurance company. But what's really interesting now is that it's not just two roundish objects, but there are two more flattened objects. And so the question is, how did these flattened objects evolve in the Kuiper Belt? Getting them to contact isn't too hard, but getting these strangely shaped objects will probably be one of the more interesting mysteries. So that, I'm going to turn it over to Steve.